Hello, everyone. Good morning, good afternoon, and good evening to everyone who's tuning in. On behalf of Petro, Arab Oil and Gas Academy, and SPE Egypt section, I'd like to welcome you to today's session. My name is Shahad Bahjat. I'm a third-year petroleum engineering student at KNU in Kurdistan, Iraq, and I'll be your moderator for today. Before we start, I'd like to remind you to please drop your questions in the Q&A section below. Please keep the chat box professional and ethical, and please submit your quizzes before the deadline. Now, without further ado, please give a warm welcome to Engineer Marwa Hassan, who will be giving us a short course that consists of 4 webinars on practical applications on digitalization in the oil and gas industry. Engineer Marwa Hassan holds an MSc in Nuclear Engineering. She is the Global Production Technical Marketing Manager for Schlumberger Digital and Integration segment based in Houston, US. Marwa's experience is on defining, delivering, and communicating digital solutions around production data acquisition, surveillance, analysis, and optimization. Prior to her current role, Marwa held a variety of positions in the Middle East and Europe, focusing on digital oil field and integrated operation implementation. She was also involved in many digital solutions that range from automating one simple routine task up to complex production optimization solutions. Prior to joining Schlumberger, Engineer Marwa spent 3 years as a nuclear engineer in Egypt's second research reactor and as a lecturer in Alexandria University. Engineer Marwa has delivered more than 200 courses and presentations globally. Her latest paper on digitalization was recently featured in GAPT, Japan Association for Petroleum Technology, with the title From Digital Oil Field to Operational Excellence. Engineer Marwa, thank you so much for coming, and the mic is yours.
Thank you very much, Chad. Thanks a lot for this warm introduction. And thank you all for attending this course. As Chad mentioned, we're going to have like 4 sessions talking about the digitalization in oil and gas. And I'm very passionate about this topic specifically because many engineers, many petroleum engineers, and many people think that digitalization is related to IT. And that's why when I discussed with Professor Ahmed the importance of starting thinking about digitalization as early as possible, he agreed with me, and I'm going to take this chance to introduce what do we do in digital, or what do we mean by digital in oil and gas. And it's a very heavy topic. I know that, and I'm very well aware of that. So if you have any questions or if you need any information, please feel free to drop the questions for me. Now, for the purpose of this session specifically, we're going to talk about the current status of digital in oil and gas, which is mainly a word that you all heard about, which is digital oil field. That's what we currently have. On the next session, I'm going to show you the future of the digital in oil and gas. So something related to artificial intelligence, machine learning, specific solutions that takes us a mile away from how we currently deliver KPOs on oil and gas. I'm a bit of a business person, so I'm going to use business terms. If you don't know or you don't understand any of those terms, please feel free to ask me anytime. Now, the objective of basically this presentation is 3 important things that I want you to get away from this session. First of all, what is digital oil field? Digital oil field has been in the industry for more than 15 years right now. It's been evolving, but it exists. So I'm assuming that I'm talking to students who will soon be part of the oil and gas industry. When you join a company, you will hear a lot the word digital oil field. And then I'm going to take a slide or 2 to explain to you why you should care as a petroleum engineer. Why do you care about the digital? And why do you want to be part of the digital revolution, not only leave it to IT or software engineers? And then in this session, we're going to talk about one example of digital oil field implementations in Samarang, Malaysia. And if we have time, I'm going to show you something about what we're going to discuss the next session, just to get you, give you a little bit flavor of what we have. Now, digital oil field, you probably heard or you will read a lot about many terminologies. Schlumberger, we use the word digital oil field. BP use the word smart field. Others use the word I field. If you're working in Kuwait, we have Kuwait digital oil field. If you work in Malaysia, you probably heard about asset optimization. So there are many differentiations or many terms that you will hear when you start working in oil and gas, all lead to the same terminology, which is the digitalization of oil and gas. What is the objective? Why do we do a digital oil field, or why do we care about digitalization in the oil and gas industry? It's because we're looking into 4 important parts. First of all, increasing the efficiency. We want people to work smarter. We want things to happen quicker than possible. Accelerating production. All the oil and gas producers, the E&P companies, are looking to get production as soon as possible from hitting the ground. Reducing losses. You want to minimize the amount of time you spend in shut-ins. You want to minimize the amount of time you spend inspecting machines and inspecting failures. And as soon as possible, you want to maximize the recovery from oil and gas, right? As a petroleum engineer, so this is the KPOs that CEOs and CEOs looks for, right? This is the higher people in the company looking for. As a production engineer or as a reservoir engineer, as a geoscience, you're looking into different objectives at this stage when you enter the company. You're looking into, you want to reduce the amount of data you're looking at, right? You don't want to look into all the data. If you're managing a 400 wells and it might happen to you, you don't want to be looking into data coming from 400 wells, right? You want to look into important information that can give you insight on what's happening on each well and where can you focus, right? You want to detect anomalies. So basically, you want the digital oil field, or you want the program that you're working at is to give you warning signs to tell you that this well pressure is increasing, or for example, to give you information such as that wax is being deposited on this well. So this is the kind of information that you expect from a digital oil field program. It links information into the applications. What does that mean? It means that you're a reservoir engineer, or you're a production engineer, you're a geoscientist, but then you realize that you cannot work alone. You need information coming from reservoir engineers. You need information coming from geoscience. You need information coming from different parts of the system. As a production engineer, as a process engineer, you guys need to work together. So this is the purpose of having a digital oil field, is to share the information and link it into different processes. I know right now, if you're in university, then you're probably working with softwares like PipeSim or Eclipse or Petrel. And those software starts and finish on a specific part of the system. So if we're talking about PipeSim, for example, for production engineer, you start from the completion and you finish by the gathering center. But that's not the reality in the oil and gas industry, right? Before the completion, you're part of the reservoir, and after the gathering center, you're part of the process system. So you need something that can give you the continuity of the hydrocarbon pathway. You also want to perform optimization. We're going to talk about this later, right? So you want to be able to understand how you can optimize your system or work to the better of the system. So that's basically the objective of why you want to implement digital oil fields. The normal applications that you have gives you huge amounts of information. It gives you huge amounts of data and analysis and diagnostic status, but basically linking those systems and applications together is what gives you the importance of understanding the full system and how you can do optimization and enhancement on the full system. So when you hear the word digital oil field, or when you hear the word asset optimization or smart field, what should you think about? You should think about any part of the system that can deliver to you the four things that we talked about: the increase in efficiency, the optimization or enhancement in production, the return of investment that the company needs. So, for example, you can look into optimizing a specific operation that you're doing, like SAGD, for example, right? So through implementing sensors that can read the data automatically from your system, automating the workflows of the SAGD, you're able to make a proper decision on what exactly the parameters that you need to introduce into the system. Another part of digital oil field could be logistics. Simply, if you look into number 2, this is in the drilling part, bringing the material. If you're working on unconventional, for example, bringing the fluids, the mud into the field. So optimizing the fleet operation. And if you're an operation engineer, this is a huge amount of cost being put on your shoulders. So optimizing the cost and the operation of the fleet, bringing the fluids and materials to the drilling and production. This is digital oil field. Another important part, if we're looking, for example, into bringing the information into people in the office. So you usually have people on the field and people on the office. The ones on the field, if you're working manually, you're getting the information on an Excel sheet, for example, or you're writing information on the Excel sheet. The amount of time you spend to correct this information and sending it into the people in the office to analyze the data and make use of it and provide information and significant recommendations to you is huge. So by making wireless connection and connectivity between the field and the office, this is called digital oil field. If you're using remote monitoring to perform inspection in any of your facilities, that's called digital oil field. So again, if we're looking into reducing downtime in any of planets or improving asset reliability, for example, that's digital oil field. The use of drones into monitoring any assets, into looking into leak detection into the pipelines, for example, that's called digital oil field. If you're looking into personal safety, HSE, reducing the amount of time that people spend in hazardous situations, for example, that's also digital oil field, right? So looking into each part of the system and optimizing each part can be called digital oil field. So as long as you're doing an optimization or increasing the efficiency using new technology could be as simple as implementing sensors or fiber optics on the field. And it could be as difficult as using drones, for example, in the field, right? So the word digitalization or digital oil field can be called on any part where you're linking technology to technology with domain, which is can be facility engineering, can be petroleum engineering, can be production engineering, to provide the ROI that you're looking for. So basically, that's a digital oil field. So to simplify this, you're an operation engineer. Why do you do digitalization? This is very simple. As a production engineer, your job, or as an operation engineer, your job is to make sure that your production rate is optimized, right? But accidents happen. And when accident happens, if you don't have a good digitalization project or a good digitalization program, your oil or your production will start to drop, right? So here you see the drop. Now, what happened is that you will not notice if you don't have a digitalization, if you don't have sensors, for example, if you're not reading, if you get information from the field every month, for example, you're going to spend some time until you detect that your production is actually being lost, that you have a loss of production or your production is being declined. So by the time you're going to take to detect the problem, you're going to spend more time analyzing what's the issue, and then you're going to take an action to bring production back to its current status, right? Now, why do you do digitalization? To bring everything faster, detecting the problem as soon as possible, analyzing it as soon as possible, bringing the production to actions as soon as possible. Detection through automated workflows by having sensors, by linking the information, as we said, together so that you're intervening in the software is as less as possible, by using analytical tools to provide you with analysis, and by maintaining well intervention activity, planning, logistics as soon as possible, you're able to save your losses from production as soon as possible, right? So, and this is a cycle. So you will perform it, you want to perform it as soon as possible or as quick as possible. Detect a warning sign that your production is declining, and a detection to the anomaly or the behavior, the strange behavior that you have, and then analyzing the tool, analyzing the situation, and taking the proper action to respond to the situation, saving the production. Now, the next sessions, we're going to talk about prediction. So I'm going to show you how actually you can predict. So instead of waiting for production to decline, which is currently, unfortunately, what we have in many of the fields, because you have a sensor, so you're relying on a current reading from the sensor that tells you that production is declining. What we want, and what we're going to discuss on the next sessions, is prediction. Before you have a decline in the production, or before the issue happens to you, you're going to be able to understand that there's something happening, and you take actions before the situation gets worse. In optimization, it's quite different. In optimization, your rate is not declining, right? But you're looking into optimizing your production. So you're looking into enhancing the well operations, enhancing the field operation, and enhancing enterprise operation. What does that mean? It means that you're looking into an integrated solution that will not only rely on the well operation, but it will rely on the full system that you have. As we said before, when you're looking into the bigger picture, where you can look into the well operation, you can look into the facility operation, you can look into the reservoir operation, but tying those or integrating the full operation together is what gives you optimization. And by optimization, I don't mean only increasing production. Optimization, by the way, might be reducing your production, but increasing efficiency, might be reducing time, it might be increasing, reducing HSE, for example, things like that. Okay, so that's when we're talking about optimization, right? Now, there are five essentials components when we talk about digital oil fields. Those components can be taken on a level, on the same level, a complete digital oil field on your field, or it can be, you can choose and pick and choose based on the workflow that you're looking for. And I'm going to show you this later. But basically, you need to look into 5 things. The first one is online data. And the reason I wrote online data and I didn't write real-time data is because many of the time people say, oh, we want to put sensors that read multi-seconds of data. But sometimes you really don't need that. It depends on the operation that you're doing. If you're looking into your reservoir, for example, and optimizing your reservoir, you having a daily data or a weekly data might be enough for you to perform the application that you want. But if you're looking into a machine, optimizing the machine, if you're looking into ESP performance, for example, then having a secondly or month or daily data or minutes of data might be very efficient. Might be it might give you the opportunity to save the ESP from failure, right? So that's the reason I wrote on online data, because you need to be smart enough to understand, do I need to put sensors everywhere? Do I need to read the data on the edge? Is it enough for me to get a monthly data from this well? It depends really on the requirements that you have. Now, the second part is automating operational tasks. What kind of tasks I can automate and minimize the human interaction on these tasks. This is something very important. Can I, for example, loading the data, do I need to have a specific operator or a specific person to really load the data, or can this be done automatically? Estimating the wear rate, do I need someone to perform, to open PipeSim or Prosper or Gap and do a well rate estimation every single day on 400 wells, or this is something that I can automate, and a production engineer can only look into those 5 or 6 wells where their well rate estimation doesn't really is not aligned with the production of this well, right? The third part is you want to minimize losses, right? That's a very important part. You want to increase production by minimizing the losses that you have. What kind of losses that you might have, for example? Losses might be things related to flow assurance issues. You have hydrate on your pipeline and you don't know about it. Knowing that you have hydrate accumulating in your pipeline will save you at least maybe 10 to 20 days of downtime required for operators to clean the pipeline, right? So as soon as possible, when you understand that you have an issue and you're able to inject methanol, for example, or able to perform a specific task that will make you lose this hydrate, then in that case you've saved from 10 to 20 days of losses of production. Effectiveness through cross-discipline collaboration, as I said before, with the digital oil field, most of the companies like BP or Shell or Petrobras, for example, Aramco, who perform digital oil field, prefer to have a collaboration center where they have reservoir engineers, they have production engineers, they have operators work together. Why? To share information and to share knowledge. I know we study each part. We have when we were in college, we have a course called drilling engineer, we have a course called reservoir engineer, but in reality, this doesn't work alone. You need to work together and collaborate together. The most effective part is technology. Technology means that you're linking, you're using sensors, for example, you're using software, you're using ecosystems, you're using cloud solutions, you're using connectivity, you're using different digital solutions to be able to connect this online data with the softwares or with the domain, the production or the reservoir domain that you have, and with your enterprise and organization, right? So for example, if you're a production engineer and production operation, and you're getting the data through sensors, and you are responsible for looking into the losses, the production losses, and preparing the production report that goes into management. You want a link between the sensors and your system, which is, for example, SAP system or Oracle, your enterprise system, your ERP system, right? Oil and gas is not only about the domain that you have, it's also about linking the system together. So at the end, you want all this information to go into an enterprise system where you can prepare your daily report or your monthly report. So that's something that's very essential when you're talking about digital oil field. Having domain is not enough anymore in the oil and gas industry. Now, do I have a very essential question that always comes to operator mind? Is do I really need to do, it seems like a lot of effort. It seems that I need to put sensors everywhere. I need to perform optimization. I need to do diagnostic. I need to do many levels of hierarchy to be able to call this a digital oil field. And it's costly. And this is something that 15 years ago, we started to do. Digital oil field was extremely costly, but not anymore. Why? Because the most important or essential part that you need to look at is the data. You need to look into two important parts. Do I have enough data to perform, to validate it, and to transmit it, and to use it on the 5 layers that you see above? Do I have this data or not? If I don't have data, can I afford to implement sensors within the field to provide me with this data? If I don't have enough money, or it's going to be costly to have a return of investment on this, can I use analytical tool to perform data, to how do you say that, to perform data prediction with the less data or the minimum data that I have coming on monthly from monthly operations, for example. Like I can test the well. What I can do, for example, with the cost that I have is test the well every month. That's what I have. Okay, perfect. So can I have any tool that predicts the missing data or the missing information that I have for me? So data is essential for me. Sorry. Data is essential for me. I need to see if I can have control over the field or not, using edge, using sensors, using connectivity. Can I transmit the data or not? Can I manage the data? Can I do validation or not? Now, above from that, there are 5 layers that, based on the workflow that you intend to do, or the challenge that you have, you need to understand. So, for example, your purpose is only to know if you have a specific issue happening. So in that case, you can only go for the layer of surveillance, right? All you need to know is, do I have an issue or not? Okay. Now, you have huge amount of wells. You're working on a field where you have 3,000 wells. You don't have enough people to really analyze the situation for you. So in that case, you want digital oil field to detect the issue, and you also want the system to identify the root causes for you and tell you where to focus. You don't have people to look into 3,000 wells, right? And so on. So based on the solution or based on the workflow that you're going to implement, you will be able to choose the layer that you want to stop at. So digital oil field doesn't have to be costly, it doesn't have to be expensive. You don't need to think about the full procedure when you're thinking digital oil field. You only need to think about your needs. What does that mean? It means that hundreds of challenges face us when we talk about oil and gas industry. When I'm looking into flow assurance, hydrates, wax, scale, salt, sorry. In that case, I'm only looking into identifying, will I have an issue or not? As simple as that. But if I'm looking into lifting and pumping, if I'm looking into ESP, for example, ESP is costly. To purchase an ESP pump, to install it, and to let it fail, and then spend time changing the ESP and shutting the well to change the ESP is costly. So you don't only want to stop on the part of surveillance. You want to predict, and you want to move into diagnostic. You want to save the ESP life, right? And the same goes into surveillance and optimization and planning on the right-hand side. When you look into asset management, you want to look into the full circle. You want to look into up-till optimization. How do I make sure that while I'm saving the ESP pump, for example, I'm not really damaging the well, and I'm not really affecting the reservoir at this process? So you want to look into the full picture together. So really, it depends on the KPIs, the key performance indicators of your field and your management. Am I looking into a quick gain, for example, or am I looking into long-term? Depends. So, for example, if you're an operator, you're a quick person, right? You're looking into seconds. You don't want H2S to leak, so that's a second of matters. You don't want gas to leak. You want to look into your compressors being optimized. So you want to be a very quick and very efficient person. You want to look into seconds of what's happening into your field. But if you're a reservoir engineer, then you're what I call the brain people, right? The people who sit with eclipse or intersect for hours and hours and hours, performing really history matching for the field and spending time. So you're really looking into years of optimization, right? You're not only looking into seconds. So you want to have information as slow as possible, and you want to have information from different part of the fields, and you want to reach the optimization part and this part, right? So again, it depends on where you're looking. Are you looking into production optimization? Are you looking into the full field optimization? Your objective, are you looking to maximizing recovery? Are you looking into anticipating production issues? It will all depend on your role in the organization and the KPOs that you're looking for. I can't explain this. This is a bit difficult to explain right now, but I'm gonna spend some time just to make you get the flavor of the tiers or the layers of digital oil field, which is the first part that we talk about. So I'm taking this from Samarang. So this is a project of digital oil field for Samarang field in Malaysia, right? So what we've done, first of all, was looking into the data, as I said, data management layer. How much data do we have from the field? Do we need to install sensors or not? Do we have a historian or not? Do we have a SCADA system or not? And based on that, we have the data management layer. And we make it connect and communicate with each other. And then the application layer. The application layer is who is going to talk to who. This will be based on the workflow tier. So before we put the application tier, we look into the workflow tier. What are we going to do? Are we going to look into the well performance? Are we going to look into artificial lift, facility monitoring, flow assurance? Based on that, we choose the applications that we will connect together to create the workflow. For example, if we're talking about artificial lift, so do we want to connect, for example, PipeSim with Prosper and Gap, for example, and create a specific workflow where we will look into the performance of the pump and then detect any issues and then predict the rate, the estimated rate based on that. If we're looking into well performance, do we need to connect Eclipse with PipeSim, for example, and look into the production rate, the issues that's happening, do we need to, and so on, right? So you look into what type of workflow you will want to do. And based on that, you connect the applications and you store the data. You call the data that you're storing in the historian and the database to be used into this application. This all is being automated. What does that mean? It means that the first three layers that you see are the layers that are provided to the end users automated. You don't interfere on it. You interfere on the visualization layer. So you get the information in the visualization layer. You know, for example, that your production rate is this amount. You would know that you have a hydrate issue, you have a wax issue, your ESP pump is alarm because you have an issue with the speed, for example, or a radiator is being broken, whatever is happening. This is the layer that you interact with. Based on that, you start diagnosing the issue and you start analyzing. So what we've done here, or what we do in the digital oil field, is that you're saving time by automating the first three layers: the data management, acquiring the data, managing the data, validating the data, and then linking this data in the information and the information that you have into the applications that will perform analysis and diagnostic and surveillance to you, and designing the workflows that you have. Now, we have around maybe 20 minutes or something, so I want to take you into an example, a real example of digital oil fields, right? What are the simple steps that we take to perform a digital oil field, and how do we think about implementing digital oil field? Now, what we have here, and I'm going to take you step by step into this. What happens is that people look into the reservoir, right, or their field, and they say, I'm having an issue. I'm having a depleted asset with stacked reservoir. I have a minimum instrumentations. I don't have a good data on the field, and I need to because it's depleted field, and I'm trying to a brown field, and I'm trying to optimize this field. I need to use enhanced oil recovery scheme to improve the sweep efficiency. So the questions were, okay, what do I do, first of all, to recognize the where to implement, how to implement the EUR scheme that I have in mind, understand who's involved in the process, what can I do to compensate for the lack of measurements that I have, and which wells will benefit from this scheme. So we start with a challenge, with an asset challenge or a field challenge, right? What we want to do is to establish a framework that will benefit the business case and implementation strategy for this. The first part that we start with is a site assessment. What does site assessment mean? It means that we look into a complete understanding to the current status of the asset. What are the available data? What are the current practices and processes? Who are the engineers? What do they do? What's the current instrumentations on the field? A complete gap analysis to understand the missing points on the asset. How many process engineers do you have? How many petroleum engineers? And who's responsible for what? Once you understand the situation, you need to understand the data situation fully. How do you capture your data? What measures of validation do you apply? How many databases do you have? Any replication of the data? The answers to all of those questions shows if your data is reliable to be utilized in digital workflows, or different measures need to be taken, such as implementing sensors, for example, in your wellheads, doing well tests more frequently, or data aggregation methods. Now, after making sure that Petronas data is reliable, there is a stage in looking into the technical and business workflows. How many wells are using multi-dynamic simulation to help in identifying your flow assurance issues, for example? If we automate specific tasks, would that save your engineer times, and so on? And then the next step is looking into resources management. What does that mean? It means, how does each person perform and accomplish a specific task? And how can we introduce this, or how can we fit this priority into the digital oil field application? And then the last is what we call change management. This is a bigger step. And the purpose we do the change management, or what does change management means, you guys will understand this perfectly. When you're at college and they introduce a new system for you, you take time to adapt to the system. And if the old system still exists, then you're probably, because we are used to our own set habits, you're probably going to dismiss the new system and go back to the old system. So when you have a system like digital oil field, where you're implementing so many processes and investing huge amount of time and money, you need to spend time training and teaching the people how to use the new system, to adapt to the new system and not to dismiss it. Now let's talk technical a little bit, right? This was more of a business slide, a bit of a high level slide of a business, but now let's talk technical. Samarang field, like any other field, they want to implement digital oil field. So we looked closely into the challenges that they have, and what did we realize? We realized that, first of all, the injection of gas was done based on assumptions. So setting an optimized strategy for gas lift will be a priority. So basically, engineers will assume that this is the amount of gas that they need to inject within each well, right? So optimizing this gas injection is a priority. Second challenge that we discovered was that due to lack of data, it took the team up to 1 month or more to realize that some wells were down. So a quick system that shows well status and notify changes is necessary. So they spend a huge amount of time to discover that wells were down and to get it back into track. And then the third challenge that we looked at was, due to lack of measurement, allocation was not correct. So well test validation and correct procedures for allocation is required. Several bottlenecks were identified, and it was to establish that applying best practices and instrumentation will give huge value to this field. Oh, a bit of a complex slide. So let's try to simplify it. Now, when you move to the next step after identifying the challenge, the first step, we've done the site assessment, we identified the challenges in the field. We now know what do we need to solve, or the problems that we need to solve on this reservoir or on this field. Now we need to move into ensuring that data is the data quality is there. If you don't, in any project in digitalization, if you don't ensure the data quality is important or is reliable, then garbage in, garbage out. Whatever you get in, whatever you're going to get out. So at this stage, data was being collected mainly on monthly basis. There was a need to have high frequency data because you're looking into optimization. So instrumenting the field and fixing any faults in current instrumentation was essential. We also spent around 3 months correcting data in the existing historian to ensure that all information is correct. Quality rules, we've done something called quality rules and aggregation. Quality rules mean that within the system, you inform the system, you know your reservoir very well. So you know, for example, that pressure will not drop below specific amount, or it will not increase beyond specific amount, temperature. So those parameters, you can put something called data aggregation or quality rules, where you're saying that an alarm will be provided if the data is below or above specific parameters, specific points. And then what we've done was that we provided a next layer or an extra layer to compare between the operational results and the theoretical results that you have. So for example, you do a monthly test to see how much is your production rate, but you can also perform a daily rate estimation using PipeSim, for example, or Prosper, right? Comparing the operational results, so comparing the well test, the rate coming from the well test with your monthly or daily production will give you an understanding if this well is underperforming, right? Now, what we want to do, once we have confidence in data, what we want to do is to move from being reactive, from discovering that there is a specific issue after 1 month, to being proactive. What does that mean? It means into looking into gas lift performance. Now, what you see here is identifying that there is an opportunity, for example, related to gas lift. For example, I hope you can see from here. I'm realizing now that maybe this is a little bit small, but let's explain it together, right? This is gas lift performance. Increasing the gas injection would reflect an increase in production, giving the engineer time to perform validation and ensure the action correct. So here you have a recommendation to increase gas lift injection into specific rate. Now, sorry. Usually, when I show something like this to engineers, they get a little bit skeptical, right? They say, if the system is giving us the recommendations, what's the benefit of having an engineer? And there is an important benefit of always having an engineer, is that this is a system. It needs someone to manage it. What does that mean? It means that if the system is giving you a recommendation, it's your responsibility as an engineer to validate the recommendation, to validate if really increasing the gas lift to this amount will give you the benefit or not. It's also your job to evaluate if economically this is advisable or not. So just because a system is giving you a recommendation doesn't mean that you need to imply or apply this recommendation. You are the person who responsible for giving the advices to the operators, right? So you are the person who will look into comparing specific recommendations, choosing the right one, and then see if economically it's advisable to do that or not. It can not only it can give you an opportunity, right? Not only we provided Samarang with opportunity, but also we looked into the risks. So here there is a risk of wax deposition. So before wax becomes an issue, it blocks the pipeline, and you need to close, or you need to shut in the well and shut in the performance of the whole network and start cleaning the pipeline. The system is able to give you a risk that you are critically, there is a wax deposition in this well, and you need to start acting on it. It also, as you see, it also gives you a recommendation, up to you to take it or not. And everything like this. You can look into high erosional velocity. We've done a specific visualization tools for Samarang, where they are able to look into opportunities and look into risks as quick as possible, and not wait for issues to happen. Now, remember when we were talking about prioritizing, if you're going to go into surveillance, if you're going to go into optimization, or if you will look only into the surveillance part, for example, what are you going to do? This is an example of how you think about that, the return of investment and operational guidelines, right? For example, you're looking into, when looking into, sorry, it's a bit, I'm trying to simplify it, but it's a bit difficult. But let's simplify it together. Now, I've given the insights to the engineers. Engineers now have the insights, right? Engineers needs to prioritize what are the workflows that, when implemented, will give highest return of investments. For example, in Samarang, there are 2 workflows that were identified that they are on top: the gas lift optimization and reviving the quitting well. And we decided to start with gas lift optimization until the field automation is complete, because the later workflow depends heavily on measurements, unlike gas lift, which depends more into simulation, right? And then we worked with Petronas to understand each workflow as is situation and design a new to-be workflow. What does that mean? It means that how do you do gas lift optimization? Where are the gaps, or why you're not performing very well when it comes to gas lift optimization? Let's change this into the insights that we've seen before. For each workflow, it's very important to identify rules and responsibility of each user. Who's gonna look into the data, who's gonna collect the data, who's gonna transmit it, who's gonna validate it, who is going to perform gas lift injection, who's going to perform optimization over the well, optimization over the field, and so on, right? And then, due to lack of data, do we go into data-driven or model-driven, right? We think about this process on each workflow that we do. So I'm just showing you that digitalization is not complex, but it's also not simple. It really depends on the workflow that you're doing. So for each challenge that you're targeting, you need to think the steps that we were talking before on each challenge. Now, this is the part that I always like, is looking into the successful case, or how did people, or what was the benefit of using digital oil field on the field challenges, right? So remember, we talked about gas lift. Samarang has an issue with gas lift utilization, right? Diagnostic, the value of gas lift diagnostic and optimization workflow is mainly for automating most of the process instead of being handled manually. What does that mean? It means that workflow will give an insight that will that the well was multi-pointing based on several parameters. The system will then check the well test parameters and perform diagnostic to confirm the multi-pointing. Then the workflow will then recommend deepest injection point to the engineer. Now, this is the part. Now, what did we do? We saved engineer time in performing this diagnostic. The engineer will run sensitivity study on operating conditions to validate the recommendation and perform any further diagnostic required. Then the office will send a request to reduce, for example, the CHP to optimize the well production, right? So it's an automated process where the system will perform specific points and will raise an alarm due to multi-pointing, will look into the suboptimal well production, then will look into the deepest injection point. Then the engineer will run sensitivity on the operating conditions and identify the issue. Then solution is being communicated to the field, right? To being performed. How much Samarang saved? I know you guys are most of you are engineers, so you care about the technical more than the business. But business is linked, especially in oil and gas, is linked to technical. So the most important part is once you've done and you invested in this workflow, how much really did you gain from it? And the gain here was that they were able to reduce the gas lift consumption from 0.9 to 0.4 million scuffs per day. And they were able to increase 200 barrels per day for production, right? So at the end, this is what you're looking for. What did you gain from implementing the digital oil field? Now let's look into another example. In this particular case, well was flowing at no beam with low flow head temperature, which was fluctuating between 60 to 80 psig, suggesting that the well was slightly surging. Now, CHP was very low and was insufficient to ensure deepest and single point of injection. We still have gas lift injection on this well. The system suggested that injection on 6th mandrel, but when the engineer performed well diagnostic, he confirmed that this was impossible. And his recommendation was to investigate the valve status, which was found fallen and was fished out, right? Then the well model recommended the optimum cord size orifice to have the highest gain, which was installed. So this is a completely different situation where the gas lift valve fallen was detected. The diagnostic of the engineer who didn't know that that the gas lift valve was not in place was to inject on the 6th mandrel, which was impossible. The system recommendation was that this was impossible to do, and the recommendation was given to fish out the fallen gas lift and to install a new mandrel. What was the benefit of using this workflow or process is to increase well production by 62 barrels per day and 0.6 million scuffs per day, which was injected extra, trying to optimize the well production. Now, another example of a workflow that was implemented in Samarang, right? In that case, the well was flowing with high gross rates. So well status immediately changed. So here you can see well notification on blowing gas, right? The well status, an alarm was given to the engineer immediately that well blowing gas condition is being detected. And the recommendation was to check the subsurface safety valves. The asset manager assigned this as a ticket to the field engineer. So this is all automatically, right? You assign a ticket to the field engineer. The field engineer will observe the FTHP dropping, which is a sign that well quit after CHP bleed off. Then he checked the subsurface safety valve status, and it was found closed and set it back to open, and well was back into production. This is all something that's being digitalized, right? So when you are in the field, detecting that the safety valve is being closed is not something easy. Changing it to open remotely is not something easy. So digitalizing allows you to perform those remotely operations within the comfort of your office, similar to how we do Zoom right now, right? I don't need to come to you to perform a presentation. I don't need to come to each person's house to present, or we don't need to meet. We meet globally through Zoom. It's the same thing. Digitalization allows you to remotely perform to remotely perform processes and application and instructions very quickly without the need to manually instruct things. So just by applying digitalization in this field, in this well or in this workflow, well was back to production, having 450 barrels per day, right? So we're almost 1 hour, and I still have some slides, but I usually honestly don't like to go beyond the 1 hour when it comes. I think this is huge, too much information to really how do you say that, to really understand it in 1 hour. So I want to stop on this part, and I'll use this into the next presentations. What I want you to get out of today's presentation before we go into the Q&A session is that when you move into digitalization, when you move into when you move into digitalization, you actually move from shifting from being reactive into being proactive. You don't wait until the issues occur or happen to you. You actually know the situations. You're very well aware of what's happening around you, that your well is not performing very well, and that your well can be optimized. You're increasing the efficiency of your team and increasing the efficiency of your productivity of the way you're working and increasing the profitability. And you're enhancing the collaboration with your team. You're not working alone. You're not relying on yourself. You're relying on many people around you, right? I will share with you this presentation. I've put some SPE papers for you to read about digital oil field, because tomorrow, the next session, we're gonna talk about the shift on digitalization. So I'm gonna show you the shift on digitalization to prediction and why this shift is happening. And we're gonna cover 2 slides that we didn't cover on this session about why you should care about digitalization as a production engineer, and why you should really take some extra time to familiarize yourself with analytics solutions, familiarize yourself with digital oil field and some of this terminologies, right? So I've come to the end of my presentation in Shahd, in case we want to take the Q&A.
Yeah, thank you, Engineer Hassan, for a very informative webinar. I'm sure the audience benefited greatly from it. In the meantime, I've collected a few questions for a quick Q&A session. The first question is, what is the difference between enterprise and field operations?
Oh, perfect. This is a very, very good question. Field operation. So let me actually know, it's easier to look into this. Let's go back into the first few slides that we have. This one. When we talk about field, we're talking about the facility, the wells, the reservoir, the wells, the network, and the gathering centers, for example, and the facilities, right? When you're talking about logistics situation, when you're talking about petrochemicals, when you're talking about ERP system or shipping points, for example, you're here going into enterprise level, right? As an engineer, you deal with, let me show you something. Yes. As an engineer, you deal with the challenges on the field. You deal with the network, you deal with the facilities, you deal with the reservoir, but putting everything together, dealing with SAP systems, for example, that will read your data and perform some calculations for you, linking these systems into HR, for example, How many engineers do you have? Are your resources optimized or not? For example, this is part of your enterprise system, right? Am I clear? Or
Hopefully so.
okay.
Yeah, the second question is it possible to face a situation where the cost of digitalization is higher than the computed ROI? If so, how does the engineer handle this situation?
Uh, Honestly, I love the questions very much. I was a bit skeptical that maybe this topic is a bit higher, but seeing the questions, I'm very very happy that we're doing this presentation. Yes, especially at the beginning when we started doing digital oil field in the industry 15 years ago, there are many situations that we faced where we discovered that we are running on a very high cost, and the ROI is not as much as what operators expected. And that's why we introduced what we called site assessment. Remember when we were looking into, where was it? When we were talking about Samarang, we talked about having comprehensive site assessments. And on the site assessment, what we do is that basically we sit with higher management and we understand the KPIs of management. We understand, okay, you want to increase production, you want to reduce cost, you want to have a proper field management. What do you want to do exactly? And then we sit with engineers and we see the way they do or the way they perform their diagnostic, their analysis, the way they want to do. And then we come up with our as is situation, and we come up with the new situation and what does the new situation will say for them. Based on that, we decide if the cost is applicable or not. Now, if the cost is not as applicable, and as we were talking, for example, we said, okay, do you have data? No. Can you implement sensors? For example? No, it's too expensive, for example, because the field is remotely established, so it's going to be very difficult to implement sensors. Okay, can we implement at least one or two sensors? No. Can we implement analytical solution to provide for the lack of data not coming from sensors, and so on, right? So right now, what you do make sure before you implement any digital oil field is to do a comprehensive site assessment. Before anything, a report that will tell you this is your return of investments, this is the current situation that you have, and this is what you're going to do to receive, to reach this return of investment, and this is how much it will cost you.
Great. The third question is, during data optimization, what are the specific steps to know which data can be useful and which is not?
This is again a very good question. The data that's going to be useful or not will depend on the workflow that you're implementing, right? So let me see. If, for example, when we were talking about Samarang, we said that we're going to do gas lift optimization, right? So is it really useful for you to collect data related to facilities, for example? You're not going to do anything on facility itself. You're focused on gas lift optimization. So the data required to do gas lift optimization as an engineer, when you're doing gas lift optimization manually, those are the data that are important to you in the workflow that you're identifying. So the first part is identifying the KPOs, identifying the workflows, and based on identifying the workflows that will give you the return of investment that you need, you can identify the data that are important to you.
Great, thank you for answering, Engineer Marwa. This concludes our quick Q&A session. So thank you again for dedicating some time of your surely busy schedule. Thank you, attendees, for tuning in from all around the world. Please stay safe, wear a mask, and have a great day.
Thank you very much, Shah. Thank you all very much, and thank you, Professor Ahmed, for your time.